Okay, what I wanted to do with this screencast is just demonstrate pretty briefly how to do the video game analysis. So this is one of our CT STEM lessons, and you have a couple pathways to go with this. The first thing that students will have to be able to do is to make a screencast, kind of like what I'm doing now, of them playing a video game. Now the lesson that we have on the wiki has to do with the example of Asteroids, the classic video game. There's a number of those online that you can play for free. And it's really just recording a few seconds of playing a video game that has motion, that's relevant to any of the physics topics that you might be studying. Perhaps it's finding speeds, finding accelerations and forces, momentum, kinetic energies, things of that nature that deal with motion. So the classic site that you go to make a screencast is Screencast-o-matic. It's just at screencast-o-matic.com. And it's very easy. You don't have to download anything. You literally can just click the Start Recording button that's up here in the top right corner. Then you can find one of the Asteroids video games. You can play these for free. Now in this case, I've played this particular site before. I'm not going to worry about doing this, but you can play a few snippets and record it and save it to your desktop or to a certain folder that you have on your computer. And then, really the gist of this, when you want to do a video analysis, perhaps you're familiar with this tracker software. If you just Google tracker video analysis, you'll find this site here, and you can go to it and you can download, depending on what kind of computer platform you have. There's Windows, Mac, and Linux installers that you can use for tracker. Some of you might have Logger Pro. Logger Pro also has a video analysis feature. So whatever tool you're using, that's really going to be the gist of doing this particular analysis. Okay, so when you're in Tracker, it'll look something like this. And if you have not used this before, it's really not that bad. It's pretty straightforward. For example, up here under video, you can import whatever video that you want to do. So once you make a screencast of the video game, you can import that into Tracker. And it just takes a few seconds. Okay, now as far as all these buttons that they have along the top, it's really just these first few that you end up using over here. There's also a slider bar down here at the bottom where you can actually go ahead and you can play your video. Okay, now I have the volume off for this video, so you won't really hear anything. But now there's also, okay, so you can see I'm starting to shoot the asteroids, but I'm especially interested in the motion. Okay, so you want to find it in this case where the spaceship here starts to first move when you first hit the rockets and it starts to accelerate forward. And these little sliders down here below the main slider bar, you can use this to set the time interval, okay, the frame that you want to start at for your analysis and the frame you want to end at for your analysis. There's another one over here at the right. Let's grab that. And again, it's probably just going to be a few seconds worth that you might actually want to capture and try to analyze. These buttons over here allow you to go frame by frame. Okay, so I'm going to click backwards, and I just want to try to find the frame where it first hit the rocket and it first starts to move. So right around here somewhere. Okay. And that's where I'm going to start the analysis. Okay, so as you do this, one of the main things that you're going to have to do is you want to measure distances. Okay, if you want to get speeds, you can literally go frame by frame. If you're using an actual video from a camcorder or from your phone, The standard for that is each frame is 1/30th of a second. In this case, this recorded the video game at 1/25th of a second. This little icon up here, if you click on this, you get some calibration tools. And much more often than not, you're probably going to use the calibration stick. This is really to set your size scale for the particular video. Now, I like Asteroids, and students like that, A, because they just like playing the game, and B, they can do some research and try to figure out like what would a reasonable size be for a spacecraft. Okay, if you're a single person little fighter out there blasting asteroids, maybe 10 meters. They would look up maybe the space shuttle on Wikipedia and get some dimensions for that. With this calibration stick, you can click on the ends and you can move this thing around. Okay, now I want to calibrate this based on the length of the ship, and I'm just going to use, for convenience, I'm going to say that the length of my ship is 10 meters. Okay, so this little box here, I can double click on that and say that, and type in 10. Okay, so now this particular distance right here, my calibration stick represents 10 meters, and now everything else is going to be set to that scale. Now, when you start doing analysis, you don't need this in your picture anymore, so you can actually click on the calibration tool again, it goes away, but that calibration scale is set. You can set up coordinates. Okay, I click on this icon, and I'm going to tell Tracker I'm going to follow the nose of my spacecraft. That's where I'm going to set the origin for my coordinate system. Okay, so now you're in a position where you can actually start creating the track. You can start to look at the motion of your spacecraft and start to get some data. Okay, so that all comes when you click on this Create button up here. And typically it's easiest to go with the point mass. There's lots of other options, and I should mention there's lots of YouTube videos on all sorts of examples of how to use Tracker. There's good help services within Tracker itself. So I'm going to click on point mass. Okay, so this is by default, it's called Mass A. You can name it if you want. And this box up here in the top left corner, you can give it a mass. You can actually, again, look in Wikipedia under the space shuttle and get a reasonable mass for a spacecraft if you wanted to. Or you can just record it off on the side. Okay, but the thing is, when you want to make the track, notice my little arrow here. Okay, I'm now going to hit the Shift button on your keyboard. When you do that, it turns into like these little crosshairs. And you can put the crosshairs on the tip of the spacecraft. And then I'm still holding Shift down all this time to keep the crosshairs. And then if you click, notice it left a little red mark there. Okay. And also over here on the right, these graphs have opened up. In this case, by default, it's going to be your x coordinate versus time over here on the x-axis. Okay, and so there's my dot. Okay, that's the position of the cone that I just marked. Now, in addition, it also advanced the video by 1 frame. You might not have noticed that because it's not moving terribly fast right now. Now, because it didn't move very far, I want to get a second point on there. Okay, to start making the motion track. It's pretty much going to overlap with that. I'm going to go ahead and click ahead a little bit. You can keep track of how many frames you advance. And plus on the graph, it'll keep track of it as well. And so you know how much time is going by if you go ahead and sort of cheat this way and move it ahead forward. I want to move it, I'm going to click until it's moved a reasonable distance where it's noticeable. Okay. Okay, so I've clicked like maybe 3 or 4 little frames. I hit the Shift button again. There's my crosshairs. And I'm going to put it back over the tip of the cone and click. Okay, you'll get this little sign the first time you do this if you advance and skip time frames. Not going to worry about that. Okay, so it has a second point now. I can go ahead and I can advance some more frames. Okay, maybe a few like that. Press Shift. Find my third point over here. Hold it there, and then I'm going to click right there. Okay. And you can keep doing this. Maybe let me do one more point. Okay, so I click Shift. Click again. Okay, so again, over on the right, it's making your data table for you. It's making a graph for you. And suddenly you start having some information. Now with the graphs, this is only showing your x-coordinate as a function of time. You're not moving sideways, so I'm not really too worried about that one. I'm more interested in seeing what the y-coordinate looks like as a function of time. So up here in the graphs, there's this plot thing, plot feature. And if I click on 2, it's going to show both the x and the y graphs. Okay, so again, the x is kind of irrelevant here since we're not moving sideways. This point is up here simply because I didn't line the crosshairs up right on the y-axis. But here's one of more interest, the actual motion. Your y is a function of time. And on this, if you click on it, okay, it'll blow it up for you, and here's an analyze feature for you. Now this is looking fairly straight. Okay, it's going to be looks like a linear fit, which is okay because it's pretty much moving at a constant speed. I just hit the rocket just to kind of get it drifting forward. You can do curve fits, which is probably the option that you'll use the most. And in this case, it gave a linear fit by default. Here's your y equals at plus b. Okay, y is a function of time. It gives the goodness of fit. The smaller this is, the better the fit. Here's your a and b parameters. Okay, your slope, which would be your vertical speed in this case. Here's the y-intercept for your equation, so you get that best fit line. And of course, once you have your velocity, if you have a mass for your simulation, whatever video game your students choose, you now can find like your momentum. If there's both x and y motion, you can find the components of your momentum. You can find accelerations. You can find kinetic energy, and you can really start to see if the numbers that you're getting, these results, make sense. Is your video game actually made for earthbound physics, or is it some just different world, or is it a different universe? You could go back and track motions of the asteroids before and after they get blown up. You can see how fast they're traveling. You can get information. It's outlined in the lesson plan. You can actually look up asteroids in Wikipedia and get densities, sizes, masses. I should show over here one last thing. Is in addition to the calibration stick, there's a calibration tape that you can move around. Let's say you wanted to measure the size of an asteroid. Okay, you can put the tip of air on one side, you can move the other tip over here and move it out. If you make that out, it's 15.54. So it's all based on the calibration stick that you used before. And so that'd be like 15.5 meters across. So you can, if you assume it's spherical, you can use densities that you find and figure out the masses of the asteroids and get those data and that information. If you're looking at a billiards video game,